So I want to recap real quick. You recording? We are. JT and Aaron both gave us the component pieces that we needed to formalize what we just did. So if you have a generalized raw score, usually it's called X. That's great, except X, a random variable X, just like it was for the binomial, has its own distribution, has its own bell curve. Remember how every binomial distribution is different too? You put a different probability in, 0.9, 0.8, 0.7, 0.5. Those curves change. Same thing with X. So I didn't give you X normal or J normal, whatever you want to call it. I gave you st normal because we can convert. Does this look familiar from the discussion we just had? Take the raw score, figure out how far it is away from average, and divide by the standard deviation. Boom. You've converted it to a z-score, which is a number of standard deviations. I mean, you guys came up with this, which is gorgeous. This is one of the formulas. I try not to teach this class as memorize a bunch of formulas and regurgitate them back. This one, you gotta know. I mean, especially if you go to 244. This is every day in 244. So, to get a z-score, you simply take the raw score, subtract the average, and divide by the standard deviation. Boom! And you get what's called a z-score, which means you get onto the curve that you can then use technology to generate. If anybody feels like they're cheating using technology, please don't. You're not. You're not. There is no other way to do it other than what we described in class on Tuesday, which was shading the curve and adding up the area. You have to do it that way. I mean, so much of what we do in this class is shorthand, like using technology to do it all, but it's all legit. It just saves us the time from having to do it manually. That's it. That's it. That's it. Sure. And once you, please, Tyler. Oh. Go ahead.
No.
You sure?
No. Yeah, I'm good.
So the idea is this random variable, whatever X is, whether it's IQ scores, later on today we'll look at pregnancy lengths. Later on after that, we looked at Mark Spitz and Michael Phelps. Whatever those are, those all have averages and they have standard deviations, just like we saw back here, right? They've all got averages and they've got standard deviations, and they're all different. The trick is you don't want them different. What you want them to be is you want them to have an average of 0 and a standard deviation of 1. That's what you want. That's what you want them to have. And that's when you can then use the normal to actually calculate the percentages that you need. So what I want to do with the remainder of the time we have today is make sure you can do the conversion back and forth. That's what I want to spend the time doing today, is making sure you can run the conversions. Because once you run the conversions, you're done. And then another 3 or 4 questions on your last exam open up to you to be able to do the Tower of Terror question that becomes doable. Like you can actually do it then. Cool? And you go through the quiz for next week. Actually, the quiz for next week you could have done after Tuesday's class, but whatever. It opens up more doors if you can. And at 244, those of you think at 244, this is a huge chunk. So let's go back to IQ. We already know the answer of this one. Dull normal, 16%. Also bright normal, 16%. So let's keep going. Here's another range. Superior. Superior is an IQ above 130. An IQ above 130.
Is that Mensa? Is it Mensa?
I think I have Mensa for the next one, believe it or not. Kelly, I think. Yep.
Oh.
We'll get to that one next. Somebody asked me that a couple years ago. I'm like, you know what? That's a great question. Let's figure out what Mensa is. So we'll Google Mensa in a second to figure that one out. So I don't know. It might be. I don't think it is, though. I think it's different enough because I wouldn't have used them as the same. I wouldn't use them as 2 different questions if they're the same. Please.
What's the max range of the IQ?
None. Good question. There is no maximum range technically, because if the way IQ is formed is dividing your mental age by your chronological age. Technically speaking, it's a continuum of scores. So you could theoretically test 600, 700, 800, 900. If a 1-year-old kid tests as a 10-year-old, that's 1,000 IQ. So there's a realistic range though, right? I think the highest, let's Google this real quick. The highest IQ ever recorded, oh man, I don't remember. I think it's Marilyn Vos Savant though, hang on. Highest IQ recorded. What the hell is Oh Pish Posh? Marilyn Vos Savant. Guinness Records highest IQ. Let's just go with that. Her IQ. Just give me your IQ score.
228.
You see it? There it is, 228. So if you think about where that is, how many standard deviations above average is that? How many standard deviations out is 228? Remember what one standard deviation is?
15.
15? So, little curve. So, one standard deviation, 2, 3,
8.5.
4. Good, Zach's already got it. See, this is why we have the formulas, because this 175. What are we at? 5, right? 1, 2, 4, 5. 190. There's 6. 215. 205. And then 220. What are we up to?
228.
1, 2, 3, 4, 5, 6, 7, 8. She's out here at 228. She's about 8.5, just like Zach said. 8.5, right? She's 8 points out of 15, which is roughly a half. There's where Marilyn is. Oh, sorry, you can't see that on. Oh, you can see it on the camera. Good. So there's Marilyn, 8 standard deviations out. So Zach, there's a technical limit. She's got the highest IQ ever recorded. The problem is, historically, they've gone back and tried to approximate what certain people's IQs were before they had IQ testing, like Newton, Isaac Newton, Albert Einstein, people like that. But the problem with that is, first of all, why would you do that? What are you going to gain from that other than writing an article? And secondly, how would you even do it with any kind of accuracy? We know that Newton was a genius. We know that Einstein was a genius. But, you know, that's sort of the point of it. So your question has kind of 2 answers. There is no, couldn't we theoretically get an IQ higher than 220 or 230 or 240? You could theoretically. It's just that it's never been done before. Now there would be a lowest IQ, wouldn't there? Technically speaking,
0.
it would be 0. I mean, I guess if you get every question wrong on an IQ test, I guess you have an IQ of 0 because your mental age would be 0 divided by whatever your chronological age is. So there is actually a limit down on this end, but it's really far out too. So there's a usable range, but the limit is not, the limit actually doesn't exist because of it. Fair? Sorry, it's a long answer to your question, but it's a good question. And that does talk about the difference between a binomial and the normal. The binomial for sure has a top end, right? If I buy 10 birds, I can have at most 10 chickens. It's not an infinite number of chickens. It's not the gambler's room. So it does point to one of the differences there. So let's talk about this superior high IQ. Can't get the screen to go down. Let's talk about this superior issue. Come back over here. Thank you for the question. All right. So above 130. Well, you might know the answer to this already just because of discussions we've had in class. But let's draw it. I always like drawing them before I go right to the answers. Right to technology especially. So superior IQ. Now, and I also, oops, sorry, 244 mode. I like drawing the curve we're on, and then under it drawing the standard normal curve we need to get to. At this point in the game, it's nice to be able to go back and forth pretty straightforwardly. So we know the average is 100. We need to know what chunk of people are superior, and the limit of superior, and that's why I put it in quotes, because this is just like dull, normal, or idiot. It's just something made up. If you're at 130 or higher, so if you're at 130.1, you are superior. 130.0009, you are superior. Right? 129.999, you're not. You're whatever's below. 130. So here's 130. I thought I saw a hand go up. Maybe. Caleb, is that you? You're just stretching. You're just stretching. I apologize for interrupting. So that is what we got to find. That's what we got to find. That's the percentage of people, Americans, I guess, or adults in general, that are superior. How are you going to do it?
Find out the rest.
2.5. Why? Because Aaron's already got an answer. And you don't even need the program to do this, do you? You don't need a program as long as you don't need 3 decimal places of precision. She's already got. Tell me how you did it.
Because it's outside of 2 standard deviations, and whatever's inside 2 is 95%. So
This corresponds to 0, right? So hold that thought for 1 second. You got it, Aaron. You got it. So here's the general curve. Here's the standard curve. We have to do the quick little conversion, right? The standard curve. We know that 100 corresponds to 0. What does 130 correspond to? 2. Well, it's got to be 2, right? Using the formula, if you want to use the formula, you do 130 minus 100, which is 30, divided by 15. or just count. 15 up is 115, 15 more is 130. So you went up 2 standard deviations. So Aaron went straight to, wait a minute, we've been talking about 2 standard deviations for like 8 weeks now, which we have. So if you tracked between 130 and 70, that would be what percent of people? Here, let's 2 standard deviations. 95%, right? 95%, which means what's this over here?
2.5.
It's 2.5, isn't it? 5% would be here or here. But these guys are just on this side, so it's that half. Is that fair?
Yeah.
2.5%. Now, believe it or not, it's actually a smidge below that, but it's usually not worth getting into a fist fight over the difference in 1/10% or 2. Could you use your TI to generate that area if you needed to?
Yep.
Of course you could. Of course you could. Grab it. Let's just grab it to make sure you know how to do it. Sounds like some of you guys have already done it, which is fantastic.